And then part B. See, let's go back to the question. It's already 2.5 pages. So part D, what is the limiting amount of C after a long time? After a long time, that means as T approaches infinity, what happened to the C? Basically, you find the limit of the solution. So take the limit as T approaches infinity of the X at T, or the limit of the expression that we found as a solution. I think my pen needs more, the new battery. For T approaches infinity. And in count 1, when you consider the limit at infinity, we look at the leading term. The leading term, that means in the long term, that term will lead the behavior of the graph. So in this case, the exponential the 1 is nothing as you go furthermore as T approaches infinity. So the leading term would be 3 times exponential e and 5 times exponential the e of the denominator. So in the long term, the limit will go to 300 divided by 5, okay, which is, what will be the number? 60. So 60 grams. So eventually, the quantity of the chemical C will be 60 grams. Okay, that's part B. And then part C asks for how much of chemical A and B remains after a long time. So remaining of A. Recall the remaining A would be like what the original amount or the initial amount of the A, which is 40, minus 2/3. 2/3 of the chemical C is from A. If you recall when we set up the model. So original 40 minus 2/3, that part of the chemical C is from A. So the remaining would be for the long time. So if X is 60 here. So 40 minus 2/3 times 60. Eventually, the chemical A will be gone or will be used. Like all will be used. So 0 gram. So this is 60. Yeah, my pen needs a battery. And then for the remaining of the B, initial amount of the B is 50, and only 1 out of 3 portions of the chemical C from the B. Remaining will be 50 minus 1/3 times 60, and that will give you, that's 20 subtracted from 50 to be 30 grams. So in the long term, B will remain 30 grams, but A will be used. The all of A will be used.